Alright, so like I said, the last test that we're going to talk about today is the root test. So we're going to talk about the root test. This infinite series converges if you take the limit of the nth root of the absolute value of an. If it's less than 0, it converges. If you take that same limit, the nth root of the absolute value of an, if it's greater than 1, it diverges. So, convergence and divergence. The root test, though, is inconclusive if you take the limit and it is equal to 1. So, two-way test, we're able to tell convergence or divergence. Okay. So, it's important, and it says right below there, if the entire rule of sequence can be written as a power of n, the root test is hard to beat. So if you can write everything to the nth power, this is going to be a very good test to use, okay? So there's not much more at the top. Well, actually, we can do a short example up top. So I'm going to give you one that's not in your notes. So if we have the summation from 1 to infinity of 2/3 to the nth power. 2/3 to the nth power. I want to solve this one by doing this way, the root test. So we would set that up as limit as n goes to infinity of the nth root, the absolute value of 2/3. Do we need to do the absolute value, or is 2/3 always going to be positive to the nth power? Yeah, it's always going to be positive. So 2/3 to the nth. If I take the nth root of 2/3 to the n, what am I getting as my value? 2/3. 2/3, less than 1, greater than 1, equal to 1. Less than 1. So what can you conclude? Converges by root test. But now I want to go back to the idea I think Eric maybe mentioned yesterday, maybe the day before, about the one test. He's like, well, do we have to do it this way, or doesn't it apply to like this other test? Well, there are certain series that are going to apply to multiple tests. Is there another way you could think about solving this one? Geometric series. It's a ratio to a power. So try to think back. It's the very first one we did. Try to think back without looking at your note card. How do we do the geometric series version? Okay, so what's r in this case? 2/3. Yeah, the ratio. So the absolute value of 2/3. So that's 2/3 if it's what? Ooh. So 2/3 is less than 1. So what do we know about? Okay, it converges by geometric series. But since we solved this one by the geometric series this time, what else can we tell? We know what it converges to. Do we remember how to find that? The first term. So 2/3 over 1 minus, and the r is 2/3. 1 minus 2/3 is 1/3. What did you say? Yes, exactly. Converges to 2. So with the root test, we couldn't tell what it converged to, but we did know it converged. But this test also, or this series also applied to the geometric series test. And with that one, we could actually tell what it converged to. So do you see how some of these now can apply to multiple tests? Are we okay with that example? All right, so now we're going to go back just doing the root test for now with the examples given so we can practice this new one, which I don't think is actually too bad, as long as you can write everything to the power of n. All right. So this first one, can we write everything as a power of n? And if you can, how would you rewrite it?
e squared over n. Yeah.
Exactly. So we're going to take the limit of the nth root of the absolute value of e squared over n to the nth power. If you take the nth root to the nth power, that's going to go away, and we're just going to be left with the e squared over n. So if you take the limit of e squared over n, is the top continually growing? Look carefully. Is the top continually growing? No, it's just e squared. E squared is some value. Is the bottom growing? Yeah, so what is the limit? 0, and that's less than 1, so what can you conclude? Converges by root test. Okay, before we go to the next example, I want to do the same example, but I want to try another test. I want to try ratio test. Let's see if we can get it to work on this one. So with this one, limit as n goes to infinity. Does anybody remember how we set up the ratio test? That's the one from yesterday. So we have the original up here. We're looking at the original. How are we going to set up the ratio test? If you need to look back, but if you can try to remember, try to do it without looking.
Limit of the absolute value of the a to the n plus 1.
Okay.
Over the n. And then, yes, so the e to n plus 2. And then you have over e to the, that over here and to n, and all of that is over e squared, e to the 2 and over n.
But that's like multiplying by, yeah. So we'll multiply by the reciprocal of the original. Are we okay with how that became 2n plus 2 here? Everybody's okay with that? We changed the n to n plus 1, but then the n plus 1 was multiplied by 2, so we distributed 2n. 2n and 2. Okay? That's how the 2n plus 2 came about. And we changed every other n to n plus 1, then multiplied by the reciprocal of the original. And we're taking the absolute value of that. So then you need to try to expand or see if anything goes away. Can we expand anything? Change it? E to the 2n, e to the 2, n to the n on the top, n plus 1 to the n plus 1, and e to the 2n on the bottom. Well, e to the 2n, e to the 2n, gone. That leaves us with the absolute value of e squared, n to the n, over n plus 1 to the n plus 1. So the e squared is just a number. Then we have the n to the n and the n plus 1 to the n plus 1. So what do you think the limit is actually going to be for this one? Careful, the powers are different. Okay. 0, the bottom is growing faster than the top. So 0, that's less than 1. So now by the ratio test, what do we know? Converges by ratio test. So again, we're at the end here. We have multiple tests in our arsenal that we're able to use when solving. And this problem here could be solved by 2 different tests. So if you're trying a problem and you're trying a test and it's not working, try another one. There may be more than one that will work. Are we okay with both representations of that problem? All right. Let's go to the last one then. All right. We have the infinite series of 3n plus 4 over 2n all to the nth power. So again, it's already raised to the nth power, so this one's an easy one. I want to use the root test because we want to take the nth root of it. So limit as n goes to infinity of the nth root of the absolute value of 3n plus 4 over 2n. And that is to the nth power. The nth root and the nth power cancel each other out. What is the limit? And your conclusion? Very good. I don't think that test is too difficult. As long as, if there's something that you already see that's recognized as all to the nth power, it really sticks out. I think if you can easily see that it can be written as the nth power, I think the root test is the way to go. And it even mentions that there, if you can write it all as a power of n, the root test is hard to beat. Okay? We're all right with that example? Root test in general we're okay with? All right, then the last thing for today, if you flip over just to mention, this might help you remember these tests a little bit. So to help you remember all of these tests, just think of Moses fleeing with the Israelites from Pharaoh. Think of the parting sea. So P is for P-series, A for alternating series, R for ratio test, T for telescoping series, I for integral test, N for nth term test, G for geometric series, and C are for the 2 comparison tests, direct or limit comparison tests. So the parting sea. And we can say, let's see, I guess it's not on there, is it? Well, you can think we did the root and the ratio test together. Alright, so for the P series, remember if P is less than or equal to 1, diverges. P is greater than 1, converge. So just a few notes for some of these. For the telescoping series, you can find the sum if you expand. So if you expand it and you cancel out your terms, you can find the sum. The integral test, whatever integral does, so does series. For the geometric series, you can find some. That is S equals A1, your first term, over 1 minus R. So we used that a little bit ago. So you can just use this area here to fill out some notes, any little tidbits of information that you want to use. Or maybe this is some information you want to put on a note card to help you study. But other than the root test, yeah, I guess it's not on there, but the parting C will help you remember. All right, any questions before we try that activity?